Hi guys, Audrey here, and this is a JAC capsule on exponent rules. In this video, we're going to go through some common mistakes that are made when simplifying using the exponent rules and talk about how to fix them. Let's go. All right, so the first thing that it's important to remember is that the only cancellation that can occur between the numerator and the denominator of a fraction is that of a common factor. So if you're having trouble with some of these words, I recommend going and looking at the PDF documents, Understanding Math Notation, that I will link down below. Also, you can check out the PDF document that goes through all of this, which I will also link down below. So what does this actually mean here? That the only cancellation that can occur between the numerator and the denominator is that of a common factor. So for this, understanding the difference between a factor, something that is multiplied, and a term, something that is added or subtracted, is important. So do not do this. Let's say that I have 2x plus 3 over 2x plus 4. Oops, 2x plus 3 over 2x plus 4. Some people like to look at this and be like, oh, look, I see some 2x's, goodbye, goodbye. That is not okay. The 2x's are common terms, they are not common factors. The 2x is being added to the 3, the 2x is being added to the 4 in the denominator. They're not being multiplied, so we cannot do this. This does not equal to 3 over 4. So do not do this. However, if we want to find a common factor, that would be something like this. If I have 2x times x plus 3 over x squared plus 1 times 2x. In this case, those 2x's are common factors because it's 2x times x plus 3 and x squared plus 1 times 2x. That's all multiplication. So in this case, canceling those out is good. And this does equal to x plus 3 over x squared plus 1. Now, question. Now can I cancel the common x's? I have an x on top. I've got an x squared on bottom. So can I cancel one of those x's? If you said no, you are correct, because now we have x as a common term, but not as a common factor. They're being added, so we cannot cancel them. This is how we would leave this. So the next thing that it's important to know is that denominators can be distributed to the different terms in a numerator, but numerators cannot be distributed to the different terms in the denominator. Now remember, terms that's separated by addition or subtraction. So what that means is we cannot do something like this. If I have the square root of x, oops, let's do that in blue. The square root of x over x squared plus 2x plus 1. Some of you might be tempted to say that this is equal to the square root of x over x squared plus the square root of x over 2x plus the square root of x over 1. But can I do that? The answer is no. I cannot distribute the numerator to the different terms in the denominator. And technically, that's what I just did. So this does not equal to that. I cannot do that. However, if I were to flip this fraction over and say x squared plus 2x plus 1 over the square root of x, then that's okay. Suddenly I can do this because now I'm distributing the denominator, that one term in the denominator, to the different terms in the numerator. So x squared over the square root of x plus 2x over the square root of x plus 1 over the square root of x. That's all good. Let's keep simplifying this. I know that a square root of x is x to the power of 1/2. So this is x squared over x to the power of 1/2 plus 2x over x to the power of 1/2 plus 1 over x to the power of 1/2. And now I know my exponent rule that says I do the numerator minus the denominator, those exponents. So this is x to the 2 minus 1/2 plus 2x to the 1 minus 1/2, because there is no value. So I've got like a little 1 hiding there. And then if I want to bring this 1 over x to the 1/2 up, which is really useful for calculus, then I'll have plus x to the negative 1/2. And my final answer here is x to the 3 over 2 plus 2x to the 1 over 2 plus x to the negative 1/2. And this, everything I did there is totally allowed. And I have a nice simplified thing where all of my x's are to a power. All right. So the next thing has to do with what we just did. We need to be careful when distributing the denominator to each of the terms in the numerator. Every term gets the denominator only one time. So what that means is something like this is not okay. Let's say I have x squared plus 3x plus x e to the x all over the square root of x. You might be tempted to say, oh, hey, look, I've got that one term in the denominator. That's great. I can distribute it to the different things in the numerator. And I can. I can say x squared over the square root of x plus 3x over the square root of x plus, can I then distribute this to both the x and the e to the x? So x over the square root of x, e to the x over the square root of x? The answer is no. That x e to the x is just one term. So this is not equal. This part is wrong. That x e to the x is just one term. It gets the denominator only one time. So what would be correct here would be to say x squared plus 3x plus x e to the x over the square root of x is equal to x squared over the square root of x plus 3x over the square root of x plus x e to the x over the square root of x. Now, let's finish simplifying this. This totally allowed. That x e to the x got the denominator one time. So this is x to the 2 minus 1/2 plus 3x to the 1 minus 1/2. And then here, that e to the x has a different base. It's not my x. So the power, my exponent rule, is only applying to the x part. So it's x to the 1 minus 1/2 all times e to the x. The e to the x just stays up there and there's nothing left in my denominator. So then this becomes x to the 3 over 2 plus 3x to the 1/2 plus x to the 1/2 times e to the x. And this is my final answer here. We're all good. All right, so the very last thing that we want to remember here is that exponents cannot be distributed in addition and subtraction. What that means is, remember that a plus b to the power of n does not equal to a to the n plus b to the n. So we cannot distribute that exponent to the inside of an addition. Also, it is important to remember that a plus b squared is not a squared plus b squared. It is a squared plus 2ab plus b squared. So with that said, do not do this. Totally not okay. If I have x plus 3 squared does not equal to x squared plus 3 squared. Do not do this. That is a horrible, horrible idea. So what are we going to do instead? This one was not okay, but what would be okay would be to say x plus 3 squared is equal to x squared plus 2 times 3x plus 9, or rather plus 3 squared. So this is x squared plus 6x plus 9. In the same way, as we've seen, radicals or roots are actually exponents. So this right here, totally not okay. The square root of 25 plus 9 does not equal to the square root of 25 plus the square root of 9, which if we keep doing this, we would see is 5 plus 3, which is 8. But we know that the square root of 25 plus 9 is not 8. Oops. The square root of 25 plus 9 is just the square root of 34. And that is definitely not 8. So that radical cannot be distributed inside. All right, guys, that is all. Those are the main mistakes that people usually make when trying to simplify with exponents. Hopefully you got something out of this, and I'll see you in the next video where we actually apply some of this stuff. Bye, guys.